Hello, this is Elizabeth from the Academic Support Center at Raritan Valley Community College, and we're just continuing to work through the problems on the Pre-Calc 2 review packet. This is hopefully try and get through most of these conic sections ones. The first question, number 21, was y plus 2 squared is equal to 8x minus 1. So the question is what is this? The first question is a hyperbola, a parabola, or an ellipse? And whenever we have one of our variables squared and the other is going to be a parabola. And whichever variable is squared is the one that's going to be the way that it's going to be opening. So this is y plus 2 squared. So because our y is squared, we're going to be opening, it's a positive y, we're going to have a parabola that looks like this. And I try and think about that like when I first do my analysis of it. In all of these conic sections, our center is always going to be, we have x minus 1, x plus 2. It's always going to be, the x value is always going to be the opposite of whatever we're adding or subtracting to x's. So it's going to be the opposite of -1, it's going to be 1. So the opposite of +2, -2. So that's our center, or in the case of a parabola, that's our vertex. I can't remember what the second question was. It was not applicable. Vertex, or what B was. It's a vertex. So to figure out the other aspects of our parabola, we want to look at the general form of the equation of a parabola. And I just wrote this over here. Usually there's this 4p. So we want to take this 8 divided by 4 to find out what our p is. 8 divided by 4 is equal to 2. This is our p. And this is your formulas. And I am not a formula person. If you watch these videos, you'll know that because I think I've said that a bazillion times. But these are your formulas, and if you want to pause and write that down, you absolutely can. But what I like to do, oops, this is 2 equals p. So p is 2. So when I do this, I like to first evaluate what kind of parabola I have, and then I want to draw my my vertex is at 1, -2. So 1, -2 is here. My p is 2. So my p, I'm going to go from my vertex. I'm going to go 2 to the left. This is going to be my focus. I'm going to go 1, 2 to the right. This becomes, oops, this becomes, I'm just going to use this to draw my line because I can't draw straight lines. This becomes my directrix. So the vertical, when I have a line opening this way, this is going to be my directrix. So this is my x equals -1. So we went from our vertex, we went 2 in this direction to get to the point that our directrix needs to go to. So 2 was from our p. So our directrix, this blue is our center. Our directrix is x equals -1. Okay. And if we look at our formulas, so this is graphically, this over here is graphically, that's how I like to do it. If we look at our formulas, we have our directrix is x equals h minus p. So in this instance, our h was 1, and we're subtracting our p of 2 to get x equals -1. Okay, and our foci, we over here, this was our foci, and that point is what, it's 3, -2. So we added p to our vertex to the x value of our vertex. The x value of vertex is 1. We added 2 to it to get to 3. Okay, and then we need our lattice rectum. So our lattice rectum is this 8 is the entire distance from our foci up and down. We're going to divide that in half. So we're going to go up 2p. So we're going to go up 4. 1, 2, 3, 4. We're going to put a point here. That's a point on our parabola, and we're going to go down 1, 2, 3, 4, and a point here. So these are the points of our parabola, the points of our lattice on our lattice rectum. And again, we can say what those are. That is 3, 2, and this should be 3, -6. No. Okay. And then now we have a pretty good idea of what our parabola looks like. Okay, so that's our parabolas. This was our focus, so let's write that here. Focus was 3, -2, and the points on our lattice rectum were this 3, 2, and our 3, -6. And if we go back, if you're formula based, if you go back over here, your foci is h plus p. So our h was 1 plus p gives us this. Oh, the last thing is our axis of symmetry, y equals k. So our axis of symmetry is the line that goes through our vertex. And all those points there. So again, this is our axis of symmetry. This is our y equals 2 is our axis of symmetry. So it's always the line that goes through our vertex. Okay, that is parabolas. The second question was 22. It's x plus 3 squared divided by 4 and y minus 1 squared divided by 1 is equal to 1. So the question is, what is this? Is this an ellipse, a hyperbola, or a parabola? So both our things are squared, and we have a plus sign in the middle. So this, is an ellipse. I didn't mean to do that, but that came up. So this is an ellipse. The center of our ellipse is always the opposite of these components. So we have x plus 3, so that's going to be minus 3 as our x component, y minus 1, so 1 is our y component. So I always just automatically just go and put this on our graph. This is -3, 1, 1, 2, 3, -1 at this point here. So this is our center, and it is at -3, 1. Okay, and this part of our formula is, oh, I didn't do that. Okay, this value under our x for our ellipses tells us where how much we're going to move in our x direction, but it's the square. So we want to rewrite this 4 squared. This 4 is equal to 2 squared. Okay, so we're going to go from this point, we're going to go up to, I put this point in the wrong spot. Sorry. This is bad. This point here, -3, 1. I went down 1. Okay, so this is -3, 1. Okay. So this 4 equals 2 squared. This 1 is equal to 1 squared. So the number below our x tells us how much we need to move in our x direction to get to our major vertices. So we're going to move 2 in our x direction. We're going to move here, and we're going to move here. So that's our major vertices. Our minor vertices, we're going to move up 1 and down 1. And we can say what these coordinate points are. This coordinate point is 3, 0, and this is 3, 2. This point here is -1, 1, and this point here is -5, 1. So we added to our x value, we added and subtracted 2 to our x value to get to our major vertices, and we added and subtracted 1 from our y values to get to our y vertices. So we can kind of draw this ellipse now. okay? And the final thing that we need to find is our foci. So for an ellipse, our foci is always going to be, C is always going to equal the square root of a squared minus b squared. So in this case, our a squared is 4, and our b squared is 1. So this is equal to the square root of 3. So again, we're going to add and subtract that because our major axis is along our x. The number under our x is bigger. So we want to add this, we want to add and subtract this from our x value of our center. So our foci are going to be at -3 plus the square root of 3, comma 1, and at -3 minus the square root of 3, comma 1. So those points are, square root of 3 is someplace between 1 and 2. So we're at like here and here. And you can draw those and label them. That's your ellipses. Let's see. I'm not going to have enough time to go through the final one, but I will make a second video for that, and I will be back. Okay. If you have any questions on the parabolas or ellipses, please feel free to reach out. We're here at the Academic Support Center for online appointments during COVID-19. Okay, shut down.